Hey everyone! Happy Thursday. Actually, not wow. This week is literally taking forever, and we still have another day. Wow. But hey, you guys get to learn a lot, so that's exciting. Um, Quizzes. Just an update on your quiz grades. Probably I want to have those done. If not by tomorrow, then over the weekend. So. I'll get all caught up in grading on that stuff. This week's been kind of crazy with meetings and stuff like that. So, yeah, we'll get those quizzes done. And then we're looking at a test next Friday over your exponent rules and scientific notation, which is what we're going to start today. And we'll do stuff with scientific notation. Oh, no, we started it yesterday. Duh. And then we'll do stuff with scientific notation as we go. So let's talk about multiplying and dividing scientific notation. So let's say I had two large numbers, 4.62 times 10 to the 12th. And we're dividing that by 2.11 times 10 to the 7th. All right, so if we're dividing scientific notation, we're going to actually use our exponent rules, which is why we learned about exponent rules first, right? So if you look here, we are dividing two things that have the same base. The tens have the same base. So if I look at this problem, I can say, all right, I could keep the 10 and subtract the exponents, and that would give me 10 to the 5th power. Hopefully you're okay with that. But these two numbers do not have the same base. So, just like before, since this is a division problem, we're just going to divide those. So I'm going to do 4.62 divided by 2.11. And that's going to give me a lot of decimals. I will tell you guys, let's go to at least 3. So go 3 decimal places, and then you can cut it off or round it from there, however you'd like to do that. So I got 2.189 times 10 to the 5th. So if I divide those two very, very large numbers, I'm going to get this number. And it's really easy to do in scientific notation because we can use our exponent rules. Right? Now there is a tricky part to this. And that just depends on what the problem is. So let's say that I'm going to divide 3.7 times 10 to the 13th divided by 5.51 times 10 to the 4th. Right? So same idea. Oh, sorry about that. Same idea here. We are dividing, and we have the same base with the tens. So I want to keep the base, which is 10, and subtract those exponents. So I'm going to keep the 10. 13 minus 4 is 9, I believe. And then over here, when I divide, because those numbers are not the same base, so we're going to just divide those. 3.7 divided by 5.51. And it gave me, and I'm going to round to 3 decimal points, 0.67, I'm going to go to 4 actually, 1.5 times 10 to the 9th. Now you're probably sitting there thinking, all right, Mr. Odie, that didn't seem so bad. It seemed like the same problem. It was. Here's the problem. What did we learn about scientific notation yesterday? We learned that this decimal has to go after the first digit. And as you can see in our answer, we didn't get a decimal after the first digit, like we did the first time we did this problem. So we have to do something here. We're going to have to figure this out. So I actually want my decimal to go here, but there's consequences for me moving that decimal, right? So what the easiest way to do this is, okay, is to think of it as if I just wrote it out in standard form. So I have 0.6715. And this was 10 to the 9th, so that means move it 9 spaces. 1, 2, 3, 5, 6, 7, 8, 9. 9 to the right. These are all zeros, right? But really, I want my decimal to go after the 6. So if I move the decimal here, what would I actually have to count to get to this spot where the number ends? Well, if I move it there, it's going to go 1, 2, 3, 4, 5, 6, 7, 8 now. So if I move the decimal here, then now this becomes 10 to the 8th. And the easiest way to do, because sometimes you're going to add, sometimes you're going to subtract. Don't be like, what do you do now, Mr. Odie? Rewrite it and count again. That is the easiest way to teach you this. Rewrite it, count again, see what happens to your exponent. But now that we are here, this is in proper scientific notation because the decimal is after the 6. Now we can be done. All right. Let's do one more division with negative exponents. Some really small numbers. And I'll probably make it so that it turns out not so pretty again. So let's do, what do you want to do? 7.44 times 10 to the negative 6th over 9.2 times 10 to the negative 3rd. All right, so now we're just dividing two really small numbers. The process does not change at all. So we're going to go, keep the base, subtract. Be careful when you subtract negatives. I know you guys aren't typically very good at this. Negative 6 minus negative 3. I like to use the add the opposite property. So if I'm trying to do this, I'm going to go change it to addition, change the next sign. Negative 6 plus 3, that makes sense to me. That would be negative 3. Remember, you can also always use your calculator, and it should show you that negative 6 minus negative 3 is in fact negative 3. And then we got to divide. So let me grab my calculator here. 7.44 divided by 9.2. And that gave me, we're just going to round, 0.8087. And again, my decimal is not where it needs to be, right? There is not a number in front of the decimal. So I'm going to have to fix this thing. So off to the side here, 0.8087. This says move the decimal 3 spaces left. 1, 2, 3. But I actually want my decimal to be right here after the 8. So if I want it to be after the 8, I'm going to just count again from there. 1, 2, 3, 4. So when I move my decimal point, it's going to be times 10 to the negative 4th. That's division. Now, you probably know this or are thinking this, but the multiplication is going to work very similarly because we're going to use the multiplication rule. So if I have 3.6 times 10 to the 8th, and we'll multiply that by, what are we going to multiply it by? How about 2.106 times 10 to the 11th? All right, so when we go to use the multiplication rule, notice we're multiplying two numbers with the same base. We got the 10s this time. So we're going to keep the 10. 8 plus 11 is going to give me 10 to the 19th. And then just like in the division rule, these numbers out in front, this time we're going to multiply them because it's a multiplication problem. So I'm going to go 3.6 times 2.106. And that's going to give me my answer of 7.5816 times 10 to the 19th. Pretty standard, hopefully, maybe. Shouldn't be too bad. Now let's do one where you gotta fix it in this one. So how about we do 6.41 times 10 to the negative 6th. And we'll multiply that by 5.535 times 10 to the negative 7th. All right, multiplication rule. We have our tens, they have the same base. We keep the base. We add the exponents. Negative 6 plus negative 7 is negative 13. Numbers out in front. We multiply them because it's a multiplication problem. So 6.41 times 5.535 is going to give me 35.479 times 10 to the negative 13th. But again, notice this time, now we have 2 digits in front of the decimal. Oh no, just like before when we had 0 digits, now we have 2. So it can't go there either. It has to go after the first number, right there. So I'm going to do the same thing I did before. 35.479. This is going to move 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But I really want it to be here. So if I move it from there, now I'm going to move it one less time. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when I move my decimal, 3.5479, this is going to turn into times 10. And now I'm only moving it 12 spaces instead of 13. And yeah, so just be careful if you have to fix your decimal on these. Everything else I think is pretty standard. But just be really careful there. You can't just assume you're going to add or subtract to your exponent. So just kind of count that out. It'll help you out. It'll give you practice putting it in standard form anyway, so that's really good. And then just be careful that when you're done, your decimal is right after the very first number. All right, you got a worksheet? Yeah, you got a worksheet today. So go ahead and do that practice, and hopefully you're all good. Later.